This is Algebraic Reasoning, Chapter 1.4, Exercises 1 through 12. And this section 1.4 has to do with exponential functions. And so let's just get on with this. I believe I'm going to do the exercises 1, 3, 5, 7, 9. I believe let's go ahead and take a look at this. For question 1 through 4, use finite difference to determine if each table represents an exponential function. Use real objects such as pennies or beans to create 4 stacks, one to represent the y value for each x value, and use the stacks to help you determine whether or not the data represents an exponential function. So what they're asking you to do here is make a visual. And so, for instance, just kind of recognize the pattern. So you have, if you have stacks of pennies, for instance, and we create 4 stacks, we're going to be able to see that instead of using pennies, I think I'm just going to make a little histogram here. So we're getting these lines straight. And so our maximum value is 54. So we'll call this 50 right here. And then this would be halfway between 50 and the axis would be 25. And then we should be able to get pretty close based on those numbers. So if we go, we say at 0, we have 2. That's going to just barely show up here. Okay, if we have 1, we have 6. Well, that's going to be about 12.56. So this will be just approximate. Let's see, 2 will have 18. Well, 18 is getting closer to 25 here, so we'll go about like this. And then 3 would be up to 54, so 3 will go way up here, just above that 50. And so we're noticing a pattern here, a growth pattern, etching out in that dotted line. So if we stack pennies, that's roughly what we would see in each stack, 0 through, and I kind of put these numbers off scale along the x-axis, but at least we should be able to see that it appears that we have an exponential function perhaps. But going back from section 1.1, we talked about geometric and arithmetic sequences. And so we can go like this and say, well, we notice on the left we're going up by 1 unit. On the right, we do not have common differences because 4 minus 2 is 6 minus 2 is 4, and then 18 minus 6 is 12, and so we do not have common differences. But if we multiply by 3, 2 times 3 is 6, 6 times 3 is 18, and 18 times 3 is 54. Yes, so whether or not the data, we say we have a common ratio, getting back to the language from section 1.1, common ratio R equals 3. Therefore, dot, 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 little triangle dot, we have an exponential function. And that'd be our answer here. Okay, let's go on to next problem. We'll say 3. Okay, again, we have the whole conversation about the stacks. And I'm going to try to do a little bit better on this one. If we have this one 0 here, 1, 2, 3. I think I have them better spaced this time. And then we have along the, say, we'll call this 30 up here. This one will be 20. This will be 10. Okay, I think we're pretty good to scale on this. So at 0 we have 0, right? At 1 we have 1. At 2 we have 8, so 2 we have 8. And at 3 we have 27, which is way up here. Okay, so we have the general shape of an exponential function. If we look at it. Okay, let's go look for our common ratio. So if we go, what times 0 equals 1? Well, there's nothing. We know we have a common difference of 1. What times 1 equals 8? Well, that's going to be times 8. Well, if we have 8 times 8, okay, that would be 64 would be the next one, but there's nothing we can multiply 0 by to equal 1. So we say we do not have a common ratio not exponential. Okay. All right, let's look at 5. For questions 5 through 8, identify if each table represents an exponential function or not. If the table represents an exponential function, identify the common ratio. So again, a little additional step here. And let's go ahead. On the left side, we're going up by 1, 1 to 2, 2 to 3, 3 to 4. Okay, and all these are plus 1 on the right. We are going 4 minus 2, we have plus 2. And 6 minus 4 is plus 2. And then plus 2. So, or not, okay? We have a common ratio. We have a common difference. Which we called in our earlier lessons D. So since we do not have a common ratio, the function is not exponential. Okay, so that's it. Next, we're going to go to next on number problem 7. See, this time let's go ahead and see if we have a common ratio. Now, what I'm going to do is I'm going to take 4.5, second term, divided by our first term, and see what that is. And next, we're going to take 6.75, our third term, divided by our second term, and see if we get the same thing. If we get the same thing, that would seem to indicate a common ratio. And then we're going to have a fourth term, 10.125, divided by the third term, which is 6.75, and see what that gives us. So let's go to our calculator, and here we have let's get a calculator page here. Wake up this calculator, and there it is. It's sitting here lifeless on the computer. So we take 4.5 divided by 3. Well, we get 1.5. Next one, we're going to take 6.75 divided by 4.5. 1.5. I think I know where this is going. The last one you put in 10.125 divided by 6.75. 1.5. So that'd be 3/2. 5, 1.5. So we say common ratio R equals 1.5. Okay, so there it is. Here, here, and here. Okay, now to fully articulate it, since there is a common ratio the function is exponential. And it says, if the table represents exponential function, identify the common ratio. We had to find that there was a common ratio. And so we will just say R is equal to 1.5. Or I guess we could say 3/2. So that would be our answer to problem 7. Okay, next. Go to 9. And for questions 9 through 12, use the situation below. So I think what I'm going to do is just kind of start this out with number 9 perhaps, and not do a whole lot more. It says your sheet of paper is 0.1 millimeters thick, and the paper is folded in half. The total thickness of layers of papers is 0.2 millimeters. So you fold successive layers in half, and so what are you going to do? You're going to multiply by 2, right? And so if we multiply by 2 again, what does this thickness of 0.2 become? Well, it's going to become 0.4. And if we follow the same thing, fold and 2 again, we'll have 0.4 times 2, which is going to be 0.8 millimeters. And for the last fold, we have 0.8 times 2, which is going to be 1.6 millimeters. Okay, so that really fills out the table. And then does this situation represent a linear function or exponential function? You can see this is what? Is that a common difference or a common ratio? 11, which of the following represents the function that models this situation? And you can just go back in here and plug in to the different equations on these answer choices and see which one gives you the correct answer. I believe I know what it is. And then here, 12, which of the following statements are true about the situation? So you can just pick these out and figure. So really, that's all there is here on this exercise set. Good luck, and thanks for viewing.